Find the intervals of the function on which the function is increasing, decreasing, or constant. So here's my function, f of x equals x to the third minus 3x. Now let's go to the calculator. So here you can see I entered in the function already, y1 equals x to the third minus 3x. Now we'll do zoom 6 for a standard window graph. And the function actually shows up pretty nicely right here, so we'll just leave that alone. So what happens here is the function is going uphill from the left, which means it's increasing, and then it hits a local maximum, and then goes downhill, which means it's decreasing, hits a local minimum, and then increases again. So we want to know the intervals where you're increasing and decreasing. So what I need to do is determine where the local max and local min are, what those values are, and then we can go from there. So second calc, and I'll do the local maximum first, so that's 4. Then the left bound of the interval, over to the right, enter again, guess, enter one more time, and there's the local max. And really what this is saying is x equals -1. It's just a round off error that happens with the calculator. So x equals -1, that's going to be the first point we use in separating the function up into intervals. Now let's look at the minimum. Second calc, 3 is minimum. Now enter right about there for the left bound. Enter again for the right bound, guess, enter one more time, and x equals 0.999992. Again, there's round off error, so it's really saying x equals 1. So our maximum is at -1, minimum is at 1. So that means that the graph is increasing all the way until x equals -1, where it turns around and starts going downhill, where it's decreasing until x equals 1, then it turns around again and starts increasing. So we have an increasing interval, a decreasing interval, increasing interval. Now here's how you would write that. Increasing, open interval of -infinity to -1, and then decreasing, open interval -1 to 1, and then increasing again, on the open interval of 1 to infinity. These are all open intervals. We never include the turning point in terms of increasing or decreasing, because at that turning point it is not increasing or decreasing. And you wouldn't even call it constant either. It's just a turning point, and that's something totally separate. Okay, so here are our increasing and decreasing intervals.